is very easy and very common for development, right? So it is an easy way to represent a set within an integer, right? So let's understand how exactly do we associate a set and an integer. So if the ith bit in the binary representation of an integer, if we do the binary representation of an integer, right, like we have 47, right, and we are getting this binary representation, right? So if the binary representation for the ith bit is coming what 1, right, then the I belongs to what set, otherwise it doesn't. What does it mean? Let's understand the example. So if we'll talk about this one, right, so these are we can say these are the sets that belongs to that position. Okay, so if we have 47, we have another example that you will understand. This example we have given in our example 1. Okay, so we have given 4 6 7 7, right? So if you'll call the index 0 1 2 3, correct? So its indices, if I'll take as a set, right, so we have 0 1 and 3. We are considering 0 1 and the last index. Okay, so if I'm considering this, so 0 1 and 3, so if I represent this in the binary, what will this? So I'll take 2 to the power 0, 2 to the power 1 and 2 to the power 3, correct? And if we'll do the sum, 2 to the power 0 is what? 1, 2 to the power 1 is 1, and 2 to the power 8 is what? 3 is 8, right? So 2 to the power 0 is 1, 2 to the power 1 is 2, and 2 to the power 3 is 8. If we'll do the sum, it will come what? 11, correct? So the binary representation, okay, so the binary representation of this number is what? 0 1 1 1. So we are getting what? 1 1, correct, here in the binary representation. So what we will do, we will consider this 0 1 7 indexes, right, for the set. So what data will come? Will come 4 6 and 7 will be our set, correct? So this was the statement we are talking. So if the ith bit in the binary representation of a integer is 1, correct, if ith bit, right, so it will come what? If that is 1, so we will consider the I element I belongs to set. So if we have given some number, right, and some number, we will generate that number, right, in the binary, and that number, if that is coming 1, then that is a what that belongs to set. Let's see another example. We'll come to this algorithm after. Let me discuss, no problem. So actually what happened, so we were here. So if n is length, right, and n is length, and we are considering the mask, right? So if we consider what, from all the indices, 2 of 0 1 and 2 n minus 1, right, means 0 to n minus 1. If we have given what n is the size, if n is the size of array, so total we will move to what? 0 to n minus 1. And if we will represent that indices, that will be our 0 to n minus 1, correct? So it is saying that the bit mask represent all its non-empty subset from 0 to n minus 1, that we have seen, right, this one 0 to n minus 1. And therefore one can iterate over all the possible non-empty set, right? So what we will do, we will iterate our bit from 0 to 1 to the power n minus 1, correct? And for all the bit, we will do what? We will build the subsequence to the bitmap, and we will iterate to 0 to n minus 1. And this algorithm we will explain again, don't worry. And if the current bit is equal to 1, then what we will do, we will get that value and we'll do bit operation, and we'll check if the sequence length is 2. After adding on the sequence, if 2 and it is in increasing order, then we will add on to the answer, right? So let's see some example, this one. Okay, so this is an example we have given, right, 4 6 7 7, right? So if we'll talk about this n, so what is n? We have size of number is 4 we have given. So if I'll take one variable that will say m, right, so m is what? One shift operator, left shift left shift operator n, correct? And if that is this, means what does it mean is we have 2 to the power n is what? 4. So it will come what? 16, correct? 2 into 2 into 2, 2 into 2 into 2 into 2, right? So if we'll calculate that, that will come 16, correct? So m is the left shift of the number, right? N. Okay, so it means the bit mask will iterate from 1 to 16, right? 1 to 16. I will repeat again. We have size n, right? N equal to 4. Then m will come left shift of n, and that is we will iterate the bit mask will iterate from 1 to 16. Okay, and each bit mask will iterate what 0 to n minus 1, that we have already seen, right? So for 1 to 16, right? For 1 to 16, each element for 1, for 2, for 3 to till what the last value, we will move to what 0 to n minus 1. Okay, it means, what does it mean? N is what 4 we have, so it means we will move to 0 to 3, correct? Or means 16 into 16 into 4 times, right? We will move, uh, that is our loop will work. Okay, next, if I'll consider that I was talking about, so if I will bit mask will move to 1 to 16. So let's suppose the first step in which we will make a loop and we will take bit mask equal to 1. So I will start from 0 to n minus 1, right? I will go to 0 to n minus 1, correct? That is this one, correct? So I equal to 0, bit mask we have taken 1, so I will start with 0, then it will go to 1, 2 and 3, correct? And what is, we'll take two variables, that is p is bit mask of right shift I, and q is with we'll check the 1 bit, right? 1 bit shift. So what we will do here, our p, if we'll check the p, so p we have what 1, so if we'll do 1 shift what I is 0, so it will become 1, correct? 1. And if we'll check p with the 1 shift, so it will come what 1 only, right? 1 shift. So it is true. If this condition is true, right, means we are getting true here, right? Means p is coming what 1 and this is 1, correct? So this will become to 1, correct? And so the if that is the case, so what we will do, we were talking about what this is 1, right? Means q is coming 1, means that definition is true now, right? It is saying if the ith bit in the binary representation of the integer is 1, then what we will do, then element I belongs to what set, means we have to put into set. If that will not come true, right, 1, means what we will do, it means it is not true, right? It is not true, means we will not add, but it is coming true. So what we will do, at I means num at 0, num at what 0, what we have num at 0, you can see here we have 4, correct? So 4 we will add on the sequence. So we will take one sequence variable, a list we can say, and we will put on the sequence. Okay, so we got when bit mask is 1, bit mask is 1, then I will move to 0 to n minus 1, means 0 to 3, correct? In that case, what will happen, in that case, if we'll get q is true, right? If q is true, means q equal to what 1, then we will add on the this, right? Meet last, actually we are checking the last element, and that is what bit mask we are checking, right? The last the ith position of the that value is 1, means we are getting, right? The definition we have seen here, right? Here, if the ith bit of the binary representation of the integer is 1, then the element I belongs to the set, otherwise it will not add onto the sequence list, right? So what we are talking about here, see, we have taken n, we will take m, and then we will take m, correct? So n is what nums dot length we will take, and m is what 1 is less than sorry, left shift of n, correct? So what will happen, we will calculate our left shift of m, right? That is our we will calculate, right, further, don't worry. So what we'll do first here, we have our n, right? So our loop will start from what 0 to 16, right? Sorry, 1 to 16 will move here, 1 to 16, correct? 1 to 16 will move, so it is starting from here and it will go to m, that is 16 position, right? Now what will happen, will come we will have the sequence, we will when we will add on the sequence, when q is what become 1, means q is true, right? It means it is coming true, correct? So we will add at that time. If not, then we will not add, correct? That we have seen. So p and q we have already known, no, right? So we will for each mask, right, for each mask we will move to 0 to 3, 0 to 3, this loop go to 0 to 3, correct? So 3 times it will move, correct? So we will get P, then we will get Q. P is what? Right shift we will take, bit mask right shift of I for each value, and we'll check if P have the last is 1, right? P is coming 1, then we will take Q, and Q will say equal to 1, then we will add on that number, correct? Further, what we will do here, sequence dot size we will calculate, and greater than equal to 2 will say, right? So if this is coming what? Boolean, right? We will take boolean, and if size is greater than equal to 2 means we have the subsequence have at least two value, like 4 and 6 will consider, right? If that is coming, 4 and 6 is coming, and if that is only one, if that is first time it will come 4, so we will not consider this one, we will consider this one. And for that we will take this loop, right, this if condition, and we'll check if size is true, then we'll take one increasing variables increasing flag, and we'll check increasing flag. How we'll check that we'll discuss later, don't worry. And then if the increasing flag is there means 4 is next value, 6 is less than this one, sorry, greater than this one, and 4 is less than next value. So we will add onto the final list, means this subsequence is good, right? If the sequence is coming like 4 6, right, then we will not add into the final output, this one. Here we will not add on to the answer, right? So these two things we have to take care. Okay, so let's first we were at this position when step 1, bit mask is 1 and I equal to 0. Then what will happen? We have bit mask at now 1. Previously it was what? 1 only, but I was 0, right? Now I am taking I equal to 1. So if we'll take P, so what will come? P will come 1, correct? So we will P is 1, so if we'll do the shift, right, we will get what? 0, correct? P will get 0 because bit mask of 1, and that I is 1, right? So it will come 0, so we will not get the Q, right? We will not get Q here, correct? And similarly we'll go to I equal to 2, we will not get here, right? We will not get here Q, we will also not get Q here with I equal to 3. But when we will increment next bit mask is equal to 2, what will happen? We will get what bit mask and right shift will do with I, so we will get P equal to 2, right? But we will not get Q equal to 1, right? But when I equal to 1, we will get what? P equal to 1, right? And Q is what? If Q equal to 1, right, how we will get the Q? With the one shift, right? And we will get what? Q equal to true. So once if it is true, so what we will do here, num of I we will take, and we will add on to the sequence, right? So we get our first sequence when what bit mask is 1, bit mask is 2, and I equal to 1, right? So we have the sequence now. Now similarly we'll move to I equal to 2, I equal to 3, we will not have Q equal to 1, right? So we will move we will increment our next loop for bit mask equal to 3. We will check there, we have found that we will get the P equal to 3 and Q equal to 1. So this check is working found, right? Q equal to 1 is true. So what we will do, we will add on 4 here, right? So previously it was what? 6, right? Now what we have? P equal to, it will become what? We are going to add this one, right? So it is what? P is this one, and this is coming 4 6, right? Why we are discussing this? We are discard this one, right? Because the size is what? Only 1, right? The size is only 1 here. Now if we'll check here, what we are getting? Q equal to 1, right? So what we will do? Num at I, right? For the bit mask 3, right? That was bit mask 2. Now we have bit mask 3. We'll start from 0 1, and we'll move like this, right? We will found our sequence is coming what? 4 6. So final list we will add, but here we will discard, here we will discarding, because you can see the I is moving from here 0 to 3, right? And we got only only one value. So what will happen when we will come to the last one in last check? Let me go to here. When we come to here, right, this check, right? So this check will fail, right? And we will not go into adding on the onto the answer, right? So this part is run. But when we are bit mask equal to what? 3. So what we got? We got our sequence is 4 6. So we can add onto our final list, right? Now bitmask we have to increment to 4, right? So we will move like this, I equal to 0 1 2, and we'll see that we got the sequence, but after I equal to 3 we have not sequence more than 2 or equal to 2. So we will discard this one, and we will not go to the answer. So answer will contain only the previous value 4 and 6 in the as a sequence. Now we will move to bitmap equal to 5, and we will move our I equal to 0 1 2 and 3 like that. So we got here 4 and 6 in the sequence when bitmap equal to 5, right? And so what we will do, previous value we have 4 6, now we will add this one into this list here, right? And our updated answer is this one. So we it should finalist should be finalist will be updated if the subsequent size is coming greater than equal to 2, right? So here we are getting 4 7 and we are getting, right? Similarly, we will move to the next, right? Bit equal to 6, we will come to I equal to 1 0 1 2 and 3, right? So we will got here new subsequence 4 6. So previous two value we had, right? A new value we will, new subsequence we will add on to here, right? So because this will add again, right? 4 6 size sequence is greater than equal to 2, so we will add here. Similarly, we will move to I equal to bitmask equal to 7, and I will 0 1 2 and 3, correct? So we will got our 4 6 7, right? So new previous it was what, this list. Now we are going to add new one here, right? Because now it is the subsequent size is 3, right? So it will pass this one and we can add here, correct? Similarly, we'll come to bitmap equal to 8, right? And we'll see I equal to 0 1 and 3. Now we have seen sequence is coming 7, so we have to discard because it will not go to this loop, right? If condition will fail. Now we are getting I equal bitmap is equal to what, 9. So we'll get what, I equal to 0 1 2 and 3. So we will get what, 4 7 as a new subsequence, right? So previously it was what, it was sorry, it was here and here, correct? So we have added new this one and here, because it will pass this if condition and we will add here, correct? Similarly, we'll move to what, 10 9, right? And it will update our, because we are getting this one, so we will update this one. We are getting 6 7 7, so we will update this one. Similarly, we will get 4 7 7, we will update this one. Similarly, we will get what, 14 for 14, we will update this one. Now we will add 15, right? So we got new one, so we will update this one, correct? Because size is greater than what, 2, greater than equal to 2, then sequence, if sequence size is greater than equal to 2, we will add on to the answer. We'll do plus on to, we will add on to the list, right? We're doing plus. Next, what will happen, the final list will look like this one. So we have moved, we have completed all our till 6. We had what, 16 we have, m was what, our 16, and n was what, 4, right? So 16 time our bitmap will iterate for what, n size. N is what, our 4 size, right? 0 to 3, and we have collected all our sequences with the single loop, right? So what will happen here, sorry, not single loop, double loop for m and n. There was one loop for m, there was another loop for n. So you can see we have completed this one, right? And finally we have our answer, and we will return this answer as a output in our this one, right? So all the final answer will be this. So let's take a look here what I am talking about, right? So you saw that we have taken what, nums we have. So we will get our if we'll talk about 4 6 7 7, this array, we'll consider this array that we have seen. So this we have what, size is what we have, n was what, 4 we have, correct? So m we got what, 16, correct? After the left set, then we have taken one answer in the set, so that we will remove the duplicate subsequences. We will not consider the subsequence that we have already added, right? So we have seen in the 16 loop, right? We have got sometime our duplicate, right? And that we have discarded because of the set will discard its duplicacy, right? Now coming to bit, we will start this loop what, from 1 to what, 16, right? It will go to less than 16, not less than 16 means 15, till will go to 15, sorry. Next, what will happen, we will take one sequence, and it will move to what, 0 to 3, correct? Because how many elements we have? 0, 1, 2 and 3. We have 4 elements, so we will move to 0 to 3 this I, right? And for all I, we will collect our sequence. We will update our sequence for all m. For each m equal to 1 or to what 16, we will get our subsequence from what on this list, right? On this one, on this list, right? So for all I, we'll go to I to what I is what from list n minus 1, right? This means I equal to 0 to n minus 1, you can say. So for all array, right, or all array element, from all array element, we will get our what, our subsequence, you can say. And that sequence will come here, right? And we will update this subsequence after checking the size. If the size is what, greater than equal to this subsequence is, if sequence size is what greater than 2, right? So what we will do, we will add onto the our list, right? And if not, then we will not go in this one, and we will discard that subsequence, and finally we will return this one. One more thing we have left, that is this one, right? This code, this line of code we have not discussed. So what we are doing here, we have taken increasing flag. By default we have taken true. If we'll check increasing flag, and we have taken one shift, and we'll check if sequence of I, right? This one means this is our previous value, this is our next value. So like I'll take 6 we have, and next we have no, we have 4 we have, and we have 6, right? So if this is our subsequence, right? So sequence at I, we have what, 4, and sequence of I plus this one is we have 6, right? This is our I plus 1, sorry, I plus 1. So this value should be greater than or equal to this value, right? So that we are taking here. If that is the case, so we will update our increasing flag, means by default we have true, right? So we will consider that one. If that is not the case, right, then we will update our increasing flag, means anytime it will become decreasing, right? If any of the value is not getting here, right, it not satisfy, right, that will come here, it will update our true or false, right? So if that is the, if it will meant, if the subsequence is good, so it will remain true, right? And that's all we know. So guys, I think you will like this video, and if you have any doubt, please consider at least one like, share or comment. Thank you so much. And if you'll talk about the complexity, right, so this is our what will happen, we are going to loop, right? The first is what, here we are going to bit mask we are getting from 0 to m, right? Sorry, 1 to m, 1 to m, less than m minus 1, you can say. And for all m, it is going to what, 0 to n minus 1, right? Correct. So we are going, so that's why we are getting first what, 2 times we are getting, right? First we are checking each time, right, this one, and then we are adding all the value, right? And we can say consider 2 to the power n, and either the space will remain 2 to the power n into this. So we have already discussed this complexity that we have seen in the first part of this video. Please go and check the complexity, you will understand. So thank you so much. Please like, share and comment. Please subscribe so that you can get the same more videos from us. Thank you so much.